Hi everyone, so today we are gonna talk about the dynamics of actin cytoskeleton. So it's a very vast topic. In this video, we would cover the subtopic of this topic, that is polymerization or G actin polymerization. So as we know, actin filaments have the basic unit, the basic subunit, that is G actin, which get polymerized and form the actin filaments. And actin filaments, as we know, is a very important part of the cell, which is a type of cytoskeleton. So in this video we would cover about the polymerization. So the very first question arises in our mind, that how can we monitor the G actin polymerization? The answer is yes, we can monitor the G actin polymerization by four methods, that is viscometry, fluorescence microscopy, fluorescence spectroscopy, and the sedimentation. So when the G actin polymerizes, the basic subunits get attached or embedded with each other and make a fine actin filament. The the viscosity of the cell increases because the subunits are getting combined. Okay, and same with the sedimentation. The sedimentation of the cell increases as the mass increases. So it would happen in three phases. The very first is nucleation phase. It's a very lag phase or kind of slow phase. In this phase, the two or three subunits start combining, and two or three these subunits of G actin get combined and become a nucleus. So this nucleus in future get more and more polymerized to become or to form actin filaments. Okay, so the second phase then comes is elongation phase. So in this phase, the short oligomer rapidly increases in length, and it increases from the nucleus which formed in very first phase. Okay, so addition of more and more monomers at the both ends, the positive end and the negative end. And the important thing is that the polymerization happened, or additions of the monomers happen more rapidly at the positive end. Okay, then third point is G actin monomers decreases until reach equilibrium. So in the starting, G actin subunits are more in number or more in quantity, but when they get embedded with each other or polymerizes, their quantity become less and less, or they decreases, and they decreases until they reach equilibrium, or the concentration of the actin filament get increased. Okay, so the third phase is steady state. In this phase, what happens is that the G actin monomers exchange in subunits at the filament ends, but there is no net change in the total length of the filament. So in third phase, the steady state, the G actin monomers exchange with subunits at the filament ends. It means that the G actin monomers getting added and added onto the both terminals of the filament, and but there is no net change in the total length of the filament. That means that if some G actins are getting added at the end, also in turn some of the G actins are getting out or released from the actin filaments as well. So that's why there is no total change in the length of the filaments. Okay, so these are the three phases of the G actin polymerization. Or another important points I would discuss in the next video. Thank you.